Hello, in this video we'll go over the definition of one-to-one function, and we'll go over horizontal line test to see if the function is indeed one-to-one. One-to-one functions, a function is one-to-one if no two different elements in the domain have the same element in the range. That is, f of x1 different than f of x2 whenever x1 different than x2. Here is an example with the sets. If I have a set A, which is a domain, it has 1, 2, 3 values, and the set B, which is our range, this is the input, this is the output, 4, 5, 6. So if I have this relationship between the two, domain and range, this function, let's call it f, would be one-to-one. Sometimes we write it 1, 1. But if a function is looking this way, let's call it g. In this case, we have the same. If 1 is pointing to 4, 2 also pointing to 4, and you have 5, and maybe I have another value 8 pointing to 6. This is not a one-to-one function because there are two values in the domain, 1 and 2, pointing to the same value in the range. So let's call this relationship G. This is not one-to-one function, not one-to-one function. So a function is one-to-one again if no two different elements in the domain or the input have the same element in the range, which is output in here. So if we know the graph of f, it is easier to determine whether f is one-to-one. Now in this example here I showed using the set, but if we know the graph, it's easy. For example, the function whose graph is sketched below is not a one-to-one. And how we know? We know by using a horizontal line test. Horizontal line test. We draw a horizontal line and we see if it is cross this graph in two values. Let me make the graph clear here. So graph is a parabola in here. As you see, my line in red is crossing this parabola in 2 points that tell me there are two values, for example -1 and 1, that point to the same y value, and therefore it is not one-to-one. And the same with this green line in here. It crosses the graph twice, so it points to the same value. So a horizontal line test helps us determine from the graph if this function is a one-to-one. And let's see some examples here. Which of the following figures are graphs of functions? Which of the functions are one-to-one? So first we need to review, are they functions? And if they are functions, then we see if they are one-to-one functions. If you remember from the graph, to know if it is a function or not, we do a vertical line test. Vertical line test, because a one-to-one function has to be a function to begin with. So first of all, let's see if they are all a function or not. This is not a function because when x has two values for the y, so not a function. This is a review from the previous section. And this one here, it is a function. This is, yes, function. And this one also a function because vertical line test pass, so yes, function. And this one here, this is not a function. So in this example, I'm asking which of the following figures are graph of functions. So we answer the first part. Not a function, yes, a function, yes, and not a function. And here I'm using vertical line test. And to find out from the ones that are functions, which are this one and this one, we need to see if they are, if this a one-to-one function. So to find out if the function is one-to-one, we're gonna do horizontal line test. So the horizontal line test, if I cross a line right here, it looks like we are crossing the graph 3 times, so not one-to-one function. And if I use a horizontal line test here, it looks, I'm gonna cross the graph only once, and therefore it is one-to-one. So this graph here, it is a function, and it is indeed one-to-one function. The rest are, these two are not even a function, and this one here, it's a function but not one-to-one function. And again, to check from the graph, is the graph function, we do a vertical line test, and to check if it is a one-to-one function, we have to check a horizontal line test. And I hope this video is helpful.